Hi, I am B. Janardhan Reddy. In this video, I am going to tell you about what is resistance of a material, what is resistor, why color codes are used for resistors to identify its resistive value, and decoding color codes of resistors. These things we are going to learn in this video. Now, what is resistance? We know the current is nothing but the motion of free electrons in a conductor in a specified direction. So, the resistance of a conductor is defined as the obstruction to the motion of the electrons in a conductor. All the materials do not have the same amount of free electrons. So, they offer different resistances. Okay, so what is resistor? Now let us see here, what is resistor? The material which offers resistance to the motion of electrons is called resistor. So resistor is a material which offers some resistance to the motion of free electrons in a conductor. Okay, here I am showing one practical example of action of resistor in a circuit. For that I am connecting a circuit here. This is a dry cell. It has two terminals, positive terminal, and here is the negative terminal. At the bottom end we have the negative terminal, and at the top end we have the positive terminal. And here is a bulb. It has two terminals. Here is one, and at the bottom we have one more terminal. Okay, so the positive terminal of the dry cell I am connecting to one of the terminals of the bulb here. See here, and here I am leaving some gap. Okay, and the negative terminal of the dry cell I am going to connect to another terminal of the bulb here. Now the circuit is open. In an open circuit, current doesn't flow. So there is no current in the circuit because I left some gap here, and I will fill this gap with different materials, and I will check the intensity of the bulb. See here, first I will fill this gap with copper wire. Now the bulb glows brightly, you can see here, isn't it? Now I will remove this copper wire. In place of it I will put one resistor. This time also bulb is glowing, but the bulb glows dimly. That means in this case here I have connected one resistor between this gap. Because of this, less current is flowing in the circuit. So when a resistor is connected in a circuit, the current will decrease in the circuit. It offers some resistance to the motion of the free electrons. For that reason, the current will decrease in the circuit. Okay? The same I am showing here by using an ammeter how current decreases in the circuit when a resistor is connected in the circuit. So here is the dry cell. Whatever the circuit I have taken previously, the same circuit here I am taking. The only thing is that in place of bulb I am going to connect ammeter, that is milliammeter. here I am using. So the ammeter has two terminals, negative and positive terminals are there here. Depending upon the terminals we use here, the range of the milliammeter changes. If we use these two terminals, okay, so the range of this milliammeter will be from 0 to 100 milliamperes, whereas if we use these two terminals, the range will be from 0 to 500 milliamperes. So let us connect the dry cell to this milliammeter. The negative terminal of the dry cell, I am connecting to the negative terminal of the milliammeter, and the positive terminal I am connecting like this. See here, and here I have left some gap here. So in this gap I will put two different materials. One is ordinary copper wire and the other one is a resistor. Okay, see here how current will vary in the circuit depending upon the wire we connect in the gap. See here, when copper wire is connected in the gap, the current flowing in the circuit is 400 milliamperes. Okay, suppose if we connect a resistor in this gap, then current will decrease. Previously, current was 400 milliamperes. Now, current has been decreased here. Less current is flowing in the circuit because of the resistor connected in this gap. So, it is around 150 170 milliamperes current is flowing in the circuit. So, whenever a resistor is connected in a circuit, it decreases the current in the circuit. Okay, here I am showing some resistors. You can see here these are the resistors, and some color codes are there. We have to decode these color codes in order to know its resistance value. How decoding will be done, I will show you later. So these are the resistors. When a resistor is connected in a circuit, the current in the circuit will decrease. Okay. And here is a circuit symbol of resistor. We have to use one symbol. So this is a resistor. Its resistance value is 100 ohms, say, and its symbol is like this. So this is the circuit symbol of resistor. In place of this, we have to use this symbol in the circuit R equal to 100 ohms. It is like a speed breaker symbol. Now the question is, why color codes for resistors? See here, resistor color coding uses colored bands to quickly identify a resistor's resistive value and its percentage of tolerance with the physical size of the resistor indicating its wattage rating. So these are the specifications of a resistor, that is the resistive value, that is the resistance of the resistor, percentage of tolerance and wattage. These are the some specifications we have to show. So in general, color bands are used especially on resistors because they are easily printed on tiny components like resistors, decreasing construction cost. When a resistor is smaller, specifications like resistance value, percentage of tolerance and wattage are difficult to read if they are printed on it. So the color codes are used to show the specifications of a resistor. Okay, see here, generally the resistance value, tolerance and wattage rating are printed on the body of a resistor as numbers or letters when the resistor's body is big enough to read the print, such as large power resistors. But when a resistor is smaller, example 1 by 4th watt carbon or film type, the print is too small to read. So the specifications must be shown in another way. That's why we use color codes for resistors. And we have to decode these color codes in order to know its specifications. Okay, how decoding will be done, that will be shown now. Now let us learn decoding color codes of resistor. The color bands of resistors are basically of three types. 4-band resistor, see here, this is a 4-band resistor and these 4 color bands are there. 5-band resistor, this is a 5-band resistor, and 6-band resistor, and there are 6 color bands on this resistor. So we have to decode these color codes in order to know its resistive value, tolerance, etc. Now let us learn how a 4-band color code resistor is decoded. A 4-band color code resistor has 3 color bands on left side and 1 color band on right side. The 3 color bands on left side are very close to each other and the 4th color band on right side is separated from the first 3 bands with some space. See here. So it has 4 color bands. In these 4 color bands, the first 3 color bands, 1, 2, 3, these 3 color bands on left side are very close to one another, and the 4th color band is separated from the first 3 color bands with some space. Okay, so in these 4 bands, the first color band represents, indicates the first digit, second color band indicates the second digit, and the third color band indicates the multiplier, and the 4th color band indicates the tolerance. Okay, see here once again, this is the 4-band resistor. How the color codes are decoded in this, let us see. The first color band indicates the first digit of the resistor value. The first color band indicates the first digit of the resistor value. Similarly, this one, the second color band indicates the second digit of the resistor value, and this one, the third color band is the decimal multiplier, and the 4th color band indicates the resistor tolerance. So what is resistor tolerance? Let us see here. Here you can see the decoding table of a 4-band color code resistor. Okay, this is the 4-band color code resistor and these are the decoding values. Okay, so what is tolerance of a resistor? What is tolerance? Tolerance is the variation in the resistance of a resistor from its actual resistance. So the resistors of high tolerance have high variation in the resistance. The resistors of low tolerance have low variation in the resistance. For example, a resistor that has a tolerance of 5% may vary 5% of its resistance from its actual resistance value. Similarly, a resistor that has a tolerance of 8% may vary 8% of its resistance from its actual resistance value. So, tolerance of a resistor is normally specified in percentage. Okay, so this is about tolerance. So, beyond the actual the resistive value of a resistor, it can tolerate some values. To some extent, they can tolerate. Beyond that extent, they won't work. Okay, so that is called as the tolerance. So here I am decoding this resistor. See here, first digit. Here is the 4-band color code decoding table. Okay, first digit. So the first color is brown. First color is brown. The first color shows the first digit of the resistance value. So the first color is brown. So the first digit is 1. Next, second digit is green. See here, this is the second digit. Second digit is green. So it is 5. Next, the third color band is the decimal multiplier. So the third band is red. So it is multiplier. Multiplier is red in color. It is 10 to the power of 2. Decimal multiplier is 10 to the power of 2. And the tolerance. So the color band of tolerance is violet. Okay, so the tolerance value is 0.10%. So the first digit is 1, second digit is 2, that is 15 into 10 to the power of 2. 15 into 100 plus or minus 0.10%. So this is the tolerance percentage, that is 1500 plus or minus 0.10%. Okay, that is the resistive value of this resistor is 1.5 K. K means kilo, plus or minus 0.10%. This is the tolerance value. Now let us go for the 5-band color code resistor. How decoding color codes will be done in this case. A 5-band color code resistor has 4 color bands on left side and 1 color band on right side. The 4 color bands on left side are very close to each other and the 5th color band on right side is separated from the first 4 bands with some space. See here, this is a 5-band color code resistor. In this, 4 bands are left and 1 band is on right. Okay, so these 4 bands are close to each other, whereas the 5th color band is separated from these 4 color bands with some space. And let us decode this. See here, the first color band indicates the first digit of the resistor value. See here, this indicates the first digit of the resistor value. The second color band, this one, indicate the second digit of the resistor value. The third color band, this one, indicates the third digit of the resistor value, and the fourth color band is the decimal multiplier. And finally, the fifth color band indicates the tolerance. The fifth color band indicates the resistor's tolerance, that is the variation of the resistance value from its actual resistance, that is called as the tolerance. So let us decode this, how much you will get. And here is the color code table for 5 band color code resistor. So let us decode this color band. First digit. So the first digit, the first color is brown. Brown first digit means 1. Next, second color band is green. So here green is the second digit. Second digit green means it is 5. Next, third digit red. Third digit red means here it is 2. And the fourth color band is blue. So the multiplier, here is the multiplier. Blue means here 10 to the power of 6. Multiplier is 10 to the power of 6. And the tolerance is, the color of tolerance is violet. Violet means here 0.10 percentage. So first digit is 1, second digit is 5, third digit is 2. So 152 into 10 to the power of 6 plus or minus 0.10 percentage, or 152 million ohms. 10 to the power of 6 means million ohms plus or minus 0.10 percentage. Okay. So this is an example of decoding of color code on a 5 band resistor. Now let us decode the 6 band color code resistor. So here is the 6 band color code resistor. A 6 band color code resistor consists of 6 color bands. The 4 color bands on the left side are grouped together to represent the resistor's resistance value. The fifth color band, this one on the right side, represents the tolerance of the resistor, and the sixth color band, this one, represents the TCR, temperature coefficient of resistance. So here in 6 band color code resistor, we have the first 4 color bands. The first 4 color bands are grouped together, and in these 4 color bands, first 4 color bands, the first color band indicates the first digit, second digit, third digit. Fourth band represents the multiplier, decimal multiplier. Fifth band represents the tolerance, and additionally one more band is there that represents the temperature coefficient of resistance. See here the same. The first color band indicates the first digit of the resistor's value. This one. Second band indicates the second digit. Third band indicates the third digit of the resistor's value. And fourth band, you know this one, it is the decimal multiplier. And fifth color band indicates the tolerance of the resistor, and the sixth color band indicates the TCR, temperature coefficient of resistance. Okay. Now let us decode the color bands on this 6 band color code resistor. See here. The first band is brown, so the first digit is 1. Second band is black, so second digit is 0. Third band is orange, so third digit is 3. And fourth band indicates the decimal multiplier, it is red, means 10 power 2. And fifth band indicates the tolerance, okay, that is yellow color, means the tolerance is 0.02 percentage. And whereas the last band, that is brown, indicates TCR, temperature coefficient of resistor. It is measured in ppm per Kelvin. It is brown, means it is 100 ppm per Kelvin. ppm means parts per million per Kelvin. See here, that means the electrical characteristics of the resistor will change above this temperature. So what is TCR? TCR is nothing but the rate at which the resistance of the resistor changes with change in temperature is called TCR, temperature coefficient of resistance. So you know, the resistance of a conductor changes with change in temperature. So here it is 103, first digit, second digit, third digit. 103 into this is the multiplier 10 power 2 plus or minus 0.02 percentage. This is the tolerance, that is variation of resistance. So 10.3 kilo ohms plus or minus 0.02 percentage variation tolerance with TCR of 100 ppm per Kelvin, parts per million per Kelvin. Thank you.